Hey Math 1, this video is to kind of keep us rolling with the whole order of operations proofwriting. I'm just offering a few more examples for you to check out that are new and fresh. And hopefully, just with time and working through the problems, it's starting to make a little more sense. So, the ideas were, can we use the order of operations to simplify this in a clear step-by-step fashion in which we document each step with one of these properties backing it up? Okay, so I'm going to use this. I want to keep this on the entire time, so we're just going to use it in the corner here, all right? So I've got 5 bracket 1 minus 2 divided by 12 times 6 with the parentheses with a bracket and then subtract 8. So the first thing I'm going to do is write down the original statement and call it my given. If you're scratching your head about this whole given thing, it probably means you didn't watch the other videos. So we always write the first statement as the given, the left-hand side. We're trying to take the given and move it down to ultimately being a solution of -8. So when I see this, especially the parentheses inside the bracket, there's a 6 inside there. The 6 is doing nothing but just resting in the parentheses. It doesn't really deserve the parentheses at this point. So I'm going to erase it and put the implied operation, multiplication, there. So then we won't think, oh, I got to do the thing that's next to the parentheses first in the bracket, because that's not what you do first. The first thing we should do first is the division, because it's multiplication or division left to right when you do order of operations. So 2 divided by 12, 2 divided by 12, that's the same thing as the fraction 2 over 12. Yeah. Can you guys see that? I believe so. And then 2 over 12, that fraction reduces to 1 over 6. So I'm taking the 5, I'm rewriting it, brackets. By the way, this is 5 times, just to keep that in mind. There's a 1 here, minus. Take out the 2 divided by 12. Replace it with 1 over 6. Times 6, bracket, minus 8. So you would look through your list that you got yesterday in the notes. That list is going to be very important as you move forward with this chapter. That list says, hey, if you're turning division into a fraction and then reducing it, it was the very last property. If you looked at all the examples from that list that I gave you guys the other day, you'll see something very similar to that looks like 2 divided by 12 equals 1/6. So we would put in parentheses, hopefully you guys can see that, sub for the first move. All right, my next move is, there's a 5 here, 1 here. 1/6 times 1, well, that's 1. When you think about it, 6 is 6 over 1. You're multiplying reciprocals together. That always kind of neutralizes it. It gets it down to 1. If you check out your list, all right, look for things that seem to be flips of one another. I call them fraction flips. It's multiplicative inverse. You're inverting the fraction and then multiplying. So that's the multiplicative inverse property that's being demonstrated right there. Okay, the next move, we're still working inside the brackets. 1 minus 1 is 0. So 1 minus 1 is 0. You can think of 1 minus 1 equals 0 as the same as 1 plus -1. It's almost like you're adding the inverse of 1 to itself and getting 0. That's the additive inverse. And then on this move, really, there's nothing happening inside of the brackets. The brackets are protecting the 0 from what? Nothing, really. It's 5 times the bracket, 5 times the bracket, 5 times. I just want to show it's 5 times 0 minus 8. Multiplication certainly comes before subtraction, so I got to say 5 times 0 is 0. minus 8. And that's the multiplicative property of 0. Whenever you multiply by 0 and get 0, I'll use my MPOZ, multiplicative property of 0, MPOZ. And then 0 minus 8 is negative 8. And again, you check through the list and see the examples that go along with the description. Additive identity is when you add to or subtract from 0. So additive identity. And that's the end of the proof. We put a little double slash to say we got it. We documented every single step and gave the property behind it. And again, guys, this is what it means to write a proof. You document each step, both with the algebra that goes along with it and the reasoning, the property. And you're going to see these later on, so I'm hoping that this will be helpful. Let's do one more example where you have to create the proof. I'll just go ahead and rewrite it over here. Yeah. So number 2 on this notes document is 7 minus, in brackets, 4 divided by 36, parentheses 3 squared, with a bracket closing it up, and then 7 plus 4. We're showing that it equals 4. That was the original statement given. But since we're starting the proof, I'm just going to say, that's my given. We're starting the proof now. So as you analyze this, the brackets are clearly telling you, go inside the brackets, do that stuff first. The 3 squared in parentheses kind of catches the eye. Exponents come certainly before anything else inside the grouping symbols, so that's what we're going to do first. So 7 minus 4 divided by 36 times 9, because 3 squared is 9. And there's our first move. Now you would describe this move as a substitution property because it's not doing any of the special things with multiplication, and it's not doing any of the special things with addition or subtraction. All right. Next thing I would do is I would actually go back up there and say, these parentheses could be deceptive. Get rid of them and call it multiplication. So you won't be tempted to take 36 times 9 first, which is a lot of students do, and then they're just scratching their head for 10 minutes because they're like, how am I supposed to get to 4 from here? Which is the final answer. If you look at number 2, we're proving that this thing equals 4. So the order of operations state multiply or divide left to right. So take the 4 divided by 36, and let's convert it into a fraction of its simplest form. So 7 minus 4 divided by 36. Well, that would be 4 over 36. You can divide the top by 4 and the bottom by 4 to get 1 over 9. And that was also included in the substitution property. Again, there's no special multiplication. There's no special addition or subtraction. Just a generic sub. 1/9 goes in place of 4 divided by 36. All right. Hopefully it's clear that you still got to work the stuff in the brackets. 1/9 times 9 looks very familiar to 1/6 times 6. If you check that previous proof, it's 1. Bracket 1, 7, 4. So yeah, 1/9 times 9 equals 1. Check your list. The multiplicative inverse is the one that has multiply a fraction by its inversion or its fraction flip, its inverse. All right, we're getting closer. Okay, one number in the bracket. Let's step back and actually ask ourselves what's going on here. Oh, the whole time it was the bracket times 7, the bracket times 7, the bracket times 7, the bracket times 7. Since there's only one thing in the bracket, let's just get rid of it so we don't make any weird moves here. All right. So you got subtraction, multiplication, and addition. The multiplication must come first. 1 times 7 is 7. That's the multiplicative identity. Again, multiply anything times 1, you're going to get that number back. So then we should take 7 minus 7. Remember, the order of operations does not state addition then subtraction. It's add or subtract from left to right. 7 minus 7 is 0. That looks very familiar to the time in this proof where we had 1 minus 1 is 0. That was the additive inverse in that proof. So 7 minus 7 equals 0 is the additive inverse. All right, and then the last move, 0 plus 4 is 4. I believe that was very similar to the last move on our first proof. Add to or subtract from 0, and you get your additive identity out of that. All right, those are the only two proofs that I wanted to generate from scratch in this video. Just please keep at it, guys. This probably isn't going to come as naturally as, say, like an assignment on solving equations or something that you did that seemed pretty routine before. Again, I'm developing for the future, okay? So try to be patient with it and keep working hard. I am going to show you guys two examples. In which the following proof has been mapped out for you. All right, this is, I believe, the second page of the notes. And all you got to do is tell me what property backs up the move that they made. Yeah. So they basically go through an entire proof and document line by line what happened. Your job is to tell us what the property is. So the first thing they did was they took 2 to the third power and called it 2 times 2 times 2, which was 8. The property that backs it up, it doesn't have any special thing with multiplication or with addition or subtraction. So you would just say, that's the substitution property. On line 2, so we had 1/8 times 8 became 1. Line 2, I guess you got to be able to visualize that 1/8 times its fraction flip will always give you 1. The reciprocals being multiplied together is the multiplicative inverse. One minus 1 becomes 0. That's the additive inverse that we saw earlier. A lot of students will get the additive inverse and the additive identity mixed up. Something to study on. Then we got a bracket 0 with a 3 outside of it equaling 0. You're just multiplying by 0 and getting 0. So that's the multiplicative property of 0. And then to finish this thing out, we had an additive identity situation. Add 0 to something or subtract 0 from something. You get the additive identity. All right, the last thing I want you to guys, the last thing I want you to do with this video is pause it and see if you can do that on your own. All right, you've paused it, you've checked it out. Let's see what you got. So here's my given. Your job is to figure out what happened from here to here, and then you document it there. So we had 3 divided by 7, and that became 3/7. There's the first thing that happened. We had 2 1/3, and that became 7/3. So you documented the 2 moves you made. Now what property goes behind them both? Well, division. If you check your list, substitution has a clear example of that. And you also have a clear example on the sub list of a mixed number turning into a fraction. So you had 2 moves on the same line that were both subs. If you check the next step, it seemed like 7/3 times 3/7 became 1. So 3/7 times 7/3, okay, that converted into 1. Nothing else changed. Reciprocals were multiplied together. You got 1. That's multiplicative inverse. All right, next line, we went from 1 times 5 to just 5. Yeah, you multiplied by 1, that's the multiplicative identity. From here to here, 5 minus 5 became 0. That's the additive inverse if you check your list. Remember, it's like you're adding the inverse or adding the opposite and getting 0. All right, 0 times 3 is 0. So bracket 0, 3 equals 0. Again, if you just check out the first proof above us, it's the multiplicative property of 0, and very similarly, 0 plus 4 equals 4 is additive identity, just like the last couple proofs we did. All right, guys. Hey, thanks for watching. Keep working at it, and yeah, just study the examples that are written off to the side of all of these properties to get a feel for, it's second nature when you see something like this to say multiplicative inverse. Or once you see a 0 plus 4, you're not thinking inverse at all, you're thinking identity. All right, that's all I got to say. Have a nice day or evening whenever you watch this.